Hey guys, happy Friday. So first I have to apologize for, I'm going to kind of have to rush through these notes today. Let me turn up the volume here. Unfortunately, I recorded myself, great notes, taking my time and uploaded them to YouTube. And I realized I didn't share my screen the whole time. So it was just looking at my desktop, not my hover cam. So I only have 20 minutes. Ew. So I'm sorry if this seems a little rushed because it's going to be. But so here's my screen. So what we're going to do today is we're going to learn the process to subtract integers. Now, in reality, we have been adding and subtracting values the whole time. But that was because that's what the integer rule told us to do, to either add or subtract, right? If you look back at our problems, every single one of them actually started with a plus sign in between the two values. We just determined, do we add or subtract based on the integer rule, okay? So today, we're gonna look at problems like this. Now, there are a separate set of rules that I could have you memorize for subtracting integers. Or what we're gonna do instead is I'm gonna teach you how to rewrite all of these subtraction problems to addition problems, okay? So I'm also gonna chop off this piece real quick so I can explain something else when I get there. Okay. So there is a memory tool that we're going to use in order to rewrite all of these subtraction problems to addition problems. And it's going to sound kind of familiar. Keep, change, opposite. Not keep, change, flip. That's one a lot of teachers use for rewriting a division with subtraction problem or division with fractions. You rewrite it to multiply, right? Keep, change, flip. If you don't remember that, we'll get there. So this memory tool, it really does stand for almost the same, starting with keep. I'm gonna write this in words and colors. The C also stands for change, just like our other one. And then O stands for opposite. So if you can rewrite these two addition problems, there is nothing new to memorize besides that little step of rewriting first. So here's how we do that. And I'm only going to color coordinate the first one. That'll save me some time. So -6 is our keep number. Our subtraction sign is the change, and that is always the first two. And the last one is the opposite. In this case, the opposite of -5. Sometimes we'll be taking the opposite of a negative, sometimes we'll be taking the opposite of a positive. So for now, I don't need you necessarily to color coordinate, but I would recommend writing keep, change, opposite on there, okay? So we have -6 is my keep number. Then I change that sign to plus, and then I take the opposite of -5, which is just 5. Okay? Now I can combine them together using the rules that I did before. The signs are different. So I subtract the values and take the sign of the one there are more of. Right? Let's do it again. Keep, change, opposite. Keep the first, change that sign to plus, and take the opposite of +13. See, it's +13. Change it to -13. The signs are the same. Add the numbers, keep the sign. Next one, keep, change, opposite. I'm going to keep the -6, change my subtraction sign to addition, and take the opposite of 9, which is -9. And again, what do we do when the signs are the same? Add the numbers, keep the sign, -15. The next one, it looks kind of interesting because it's so small, right? Keep, change, opposite, keep my 5, change my sign to plus, and take the opposite of 18. I have two different signs. I'm going to subtract those values and take the sign of the one there are more of. Okay. This would be a perfect place to like pause and see if you can rewrite those and solve them yourself, and then press play, but no pressure. Keep, change, opposite. In fact, I'm gonna go ahead and write that for the next one also. Keep, change, opposite. Okay. So the -1 stays. My subtraction sign changes to plus, and my opposite of -11 is +11. The signs are different, so I'm going to subtract them, and there are more positives, so I keep it positive. Next one. Actually, before we do that, I always have a kiddo, I don't want to even say the word challenge me because that's not the right way to say it, but I always have a kid like, I don't understand why subtracting a negative is a positive. Like, can you prove it to me, right? And it took me a while to think about a real world situation that would make sense to you that explains why subtracting a negative is a positive. But I think I found a good one. So we're going to think of like a bank account. Okay. Let's pretend that, I start with, $500 in my account, and I slowly start charging things for that week, right? So money is coming off of my account. Let's say I go to Schnucks, spend some money on groceries. I fill up my car with gas. It's another -35. I get charged for my monthly Netflix. And then, oops, I have another monthly Netflix on accident. And then I buy a soda and some sweets. You always got to have chocolate, in my opinion. You really shouldn't go a day without it. So if I were to see a -13 charge twice, like, oh, weird, Netflix charged me twice this month. Obviously, that was a mistake, needs to be fixed. So I give the bank a call and I say, hey, there's double charge. What do I need to do to get that taken off? Little people figure out what they need to do, and that negative charge is taken off my account, right? So if you think about it, what happens to the money I have if that -13 essentially was given back to me, right? That's what happened. If that negative charge is taken away, take away a negative, right? What happened to my account is it went up by $13, okay? So it is kind of an abstract idea to take away negatives, but that hopefully helps just show you that it is reasonable to know that those two negatives, they kind of fuse together to equal one plus sign. That's how I kind of think about it, okay? All right, last one. We're gonna keep the 32. We're gonna subtract or change our sign to plus, and then take the opposite of 35, which is -35. Again, different signs, I subtract their values, and I keep the sign of the one there are more of, okay? Now, I'm sorry for how fast these notes were. I don't even know how long I've been recording right now. Oh, it doesn't tell me until the end, but all I did was, instead of talking about homework, we'll talk about homework together, okay? So if you are done before our meeting at 12:40, we're gonna meet at that 12:40 time. I'll make sure it goes on the agenda slide. I'd like you to try the little quiz that's on Canvas. I believe I labeled it, I want you to do the coach. I'll publish what I need to publish. I unfortunately saved everything for the last part of this plan hour, and now I feel like I'm scrambling, but it'll be ready for you, I promise, even if I have to give up my lunchtime. So you'll see the warm up, the notes, and whatever it's named as next. I'd like you to click that and just do those few problems in there so I know how you're feeling with subtracting integers. If we need to do this again on Monday, we will. If we're ready to start throwing in fractions and decimals again, have another practice with that, we will do that too. So just make sure you try your best, and I highly recommend making sure you write down the problem and write KCO and rewrite it before you try and find the answer. You will get better and won't always have to do that, but this first time, I highly recommend it, okay? All right, see you soon, guys. Bye.